Hey, Algebra 2. This is the second half of section 8.6. We're on the back side now. We've got a couple examples to talk about. And what I'm going to do is I'm going to go through example 4 first because it's closer to kind of what we did in the last video than example 3, which is just a little bit more advanced than that. So I'm going to do this kind of backwards. So what you'll probably need to have is you'll need to have an empirical sheet with you. So I kind of made mine a mess, I guess, a little bit, but have that empirical sheet with you so that we can kind of look some of these up, and also have this section 8.6 practice. I'm on the practice side because I'm going to do A, D, and F with you, just for examples that are in this video. Okay, so in example 4, it says the number of videos uploaded daily to a video sharing site, so maybe it's YouTube, is normally distributed with an average of, average always goes in the middle here, they call that X bar, and that is 180,000, that's what I want, 180,000, I'm going to write this sideways. And then standard deviation, sometimes they'll call it S, and sometimes they'll use this symbol, which kind of looks like a circle with a hat on him. He's called sigma. Both of those mean the same thing, but that's 3,500 videos. So what I'm going to do is I'm going to add 3,500 and add 3,500 and add 35,000 each time, and then I'm going to subtract the same way. So I'm going to turn this sideways here for a second, and I can get these numbers in here. So 180,000 plus 3,500, and I get 215. Add another 35, 250, and I guess I can do the next one in my head, 285. Add another 35. Okay, now if I start back at 180 again, I get 145. If I subtract another 35, I get 110. And if I subtract another 35, I get 75,000. Okay, so those are going to be my numbers that I get when I add and subtract for my standard deviations. Okay, so those are kind of some big numbers, but that's okay. All right, and then I always like to put this guy is 0. This would be plus 1. Adding it once, adding it twice, adding it 3 times, subtracting once, subtracting twice, subtracting 3 times. That's what those guys will be. Okay, so they want to know, find each probability. The probability that I have a number that's between 145,000 and 250,000. Okay, so 145,000 is here at the -1, and 250,000 is at the +2. Okay, so -1 to +2. What I'm doing is I'm looking on my sheet here, and -1 would be at this place right here. Okay, that's -1 standard deviation. +2 right here would be at this guy. So I'm basically looking at these 3 categories here. I'm making a mess of my sheet, but -1 to +2, those 3 categories. This is 68 right here. 34 and 34 is going to be 68, so I just need to add 13.5 to that. So 68 plus 13.5 is going to be 81.5. Okay, that's the percentage. 81.5% of the video games, or 81.5% of the time there's going to be between 145,000 and 250,000 uploaded in one day. Okay, so that's what the 81.5% is going to be. And then they say greater than 250,000. So I'm still looking at this +2, but I want to know from here and beyond. Okay, greater than that. Okay, so that's the +2 again, +2 right here. I want to know what percent is from here and beyond. Okay, so from +2 and beyond would be these 2 categories, 2.4 and 0.1. 2.4 plus 0.1, I think we've done this already before, is going to be 2.5%. So only 2.5% of the time there's going to be more than 250,000 videos uploaded in one day. Okay, so that's kind of what he looks like. All right, let's go to 8.6 here, and let's talk about like A, D, and F. Okay, just to give us a little bit more practice with this. So the scores on a test administered to prospective employees are normally distributed with a mean of 100 and a standard deviation of 12.3. So I'm going to write that out. Okay, my average is 100, so I put that in the middle. And then I'm adding 12.3 each time, or subtracting 12.3. So the first one's going to be 112.3. If I add another 12.3, I'm trying to do this in my head, is 124.6. Adding another 12.3 is 136.9. Okay, so I can do some of those in my head. I cannot subtract them. I don't know why. My brain doesn't work that way. So 100 minus 12.3. 87.7 minus another 12.3, 75.4 minus another 12.3, and 63.1. If I'm going too fast, go ahead and pause the video so you can get those all kind of written down. Okay. Here is the middle, that's a 0. This would be adding it once, adding it twice, adding it 3 times, subtracting it once, subtracting twice, subtracting 3 times. Okay. All right, so here's another one in part A that says about what percent of the scores are between 75.4 and 87.7. So 75.4, that's at a -2, and 87.7 is -1. So these two categories are right together, okay? So I just want to know what percentage is right about in here in those two, okay? So according to the empirical rule, -2 and -1, -2 is here, -1 is here. So I want to know what percentage is in between these two values. And I don't have to add anything together, it's just 13.5%. So that was kind of nice. 13.5%. So 13.5% of the prospective employees will score between a 75.4 and an 87.7, 13.5%. So part D, I'm going to go down here to about what percent of the scores are lower than 87.7 or higher than 110, or higher than 100, excuse me. So we're looking at lower than 87.7, so from here and beyond, or higher than 100, from here and beyond, right? Okay, so I'm looking at those two sections put together, right? Now, there's a couple different ways that I could do this, but I really noticed that the only section that's not taken into consideration is between 87.7 and 100. So what would be faster to do is to take the overall percentage and subtract out the percent that's between 87.7 and 100. Okay, now what percent is underneath of the entire thing if I would add all of the columns together? Okay, that would be 100%. 100% of my data is underneath of that bell curve. Okay, so if I would add all of those up, those would add up to be 100%. And the only one that I'm not looking at is from -1 to 0, or from 87.7 to 100. So from -1 to 0 would just be this chunk here, and that's 34%. Okay, so what I can do is, if this is 34% in here, 34%, not 34.4, 34%. I'm looking at this category and this category together. I would just take 100 and I would subtract 34%, and that's going to be 66%. So 66% of people are either lower than 87.7 or higher than 100 for that category. Okay, so that's kind of how D would work. You're just looking at those segments. Sometimes it might be easier to subtract. Okay, in F, okay, this one's a little bit trickier. It says if 75 people take the test. Okay, we'll deal with that here in just a minute. If 75 people take the test, how many would you expect to score lower than 75.4? Okay, 75.4 is here again. Let's go lower than that. So we're going lower than a -2. So what percentage, or how many, are lower than a -2? What percent would that be? That would be from here on this way. Okay, so what percent would that be? 2.4% and 0.1%. We've done that already. What percent is lower than that? That would be 2.5%. Okay, 2.5%. Now, I don't want to know the percentage. I want to know actually how many people that is. So if I have 75 people taking the test, how many would 2.5% be? Okay, so what I'm going to do is, if 75 people are taking the test, I want to multiply that by this percentage, but 2.5% as a decimal would actually be 0.025. Okay, so that's what I want to multiply by the 75. All right, so I just take that in my calculator, 75 times 0.025, and I get 1.875. So about 2 people. P-E-O-P-L-E. So if there are 75 people taking the test, just about 2 of them will score lower than a 75.4. The 75.4 is a really low score, technically, on this bell curve. Okay, so 2 people will score lower than that, all right? And that's kind of some different examples of those. I wanted to go through those just because that's stuff that we kind of haven't really done before. Okay, so going back to example 3, one more thing that I want to add on here, and this is kind of hard for people to wrap their head around just a little bit. So I'm gonna talk about this average and standard deviation heights of teens. We looked this up 2 years ago, so these might have changed, but this is what Google said was the average height of a teenage boy, 6 foot or 67 inches, which is 5'7", 5 foot 7 inches, and 63.9, which is 5 foot 3.9 inches. And then each one of these has a standard deviation of 2.76 and 2.4. So looking at that, okay, this 2.76 has a higher standard deviation than what this one is. So think about boys and girls. Are boys going to have a wider range of heights or a more narrow range of heights? Okay, because the standard deviation is larger, those are going to be more spread out, right? Those data values are going to be more spread out on the bell curve. So this one is going to have a larger range of heights. Maybe you might have a boy that's 5'2" and a boy that's 6'4". I don't know. And girls are going to be a little bit closer together than that. Okay. All right. So one thing that they're going to introduce to us is a Z value, or sometimes they will call it a Z score. Okay. In stats class, we deal with a Z score just about every single day. Okay, and what I went ahead and did, and you don't have to write this out, just kind of watch what I'm doing here, is I went ahead and wrote out those boys and girls information here, and I created bell curves for each one of them. Okay, so 67 is the middle here, 63.9 is the middle here. I added 2.4 to the girls and subtracted 2.4 from the girls. So this would be the 0, adding it once, adding it twice, adding it 3 times, subtracting it once, subtracting it twice, subtracting it 3 times. Don't try to copy these down because you won't have time. So 2.4 is what I'm adding each time and subtracting each time. In the boys, I started with 67. I'm adding it 2.76 once, adding it twice, adding it 3 times, subtracting it once, subtracting it twice, subtracting it 3 times. Okay, so that's what those guys are. Now a z-score is just these numbers down below here. Okay, it has to do with how many standard deviations they are away from the mean. Okay, so if I am a teenage boy and I am 72.52 inches exactly, my z-score is going to be 2 because I am exactly 2 standard deviations above average. Okay, for girls, maybe I am 59.1 inches exactly. Okay, that means I am exactly 2 standard deviations below average, and this would be my z-score. So your z-score just is these numbers that reflect those down below. Now, you will have people that are not exactly, on the dot, each one of these. So let's say, like, what if we are trying to find 65 inches? Okay, what if I have a girl that's 65 inches? Well, where do they live? They're going to live somewhere between a z-score of 0 and a z-score of 1. And here's how you calculate that out. Okay, so if I'm looking for 65 inches, okay, that's above average a little bit. And what I would do is I would take 65 inches and I would subtract 63.9. Okay, to figure out how far above average they are. So 65 minus 63.9 is like 1.1, I think, something like that. And then what I would do is I would divide that number by the standard deviation, which is 2.4. 2.4, okay? So I'm subtracting how far he is above and dividing by 2.4. So 1.1 divided by 2.4, and that gives me 0.45, okay, or 0.46. So his z-score isn't 0, it's not 1, it is 0.56, which is partway between 0 and 1. That's what his z-score would be, okay? So there's what that guy is, all right, that girl, actually. So the formula for finding a z-score is the value that we have, okay, value that we have minus the mean divided by the standard deviation. Okay, that's what this formula says right here. Okay, or they write it x minus x bar divided by the standard deviation. It's the value that we have, which was the 65, minus the average, which is 63.9, divided by the standard deviation of 2.4. Okay, that's how we calculated it down here, right? So now here, this is the reason why z-scores exist. So for example, here's my 2 examples. Okay, I'm going to do 2 examples, and let's say I have a girl that's 68 inches tall, and I have a boy that's 70 inches tall. Okay, so I want to be able to compare those two, but that's not fair to compare a girl to a boy because boys are on average taller than girls. So basically what we're saying here is 68, is that a really tall girl, or is 70 inches a tall boy? Okay, so which one is taller with respect to their specific gender? Is 68 considered a taller girl? Then 70 is considered a taller boy. And so what I do is I calculate the z-score for each one, and I figure out which one is more extreme. Okay, that allows me to compare them. So 68 is going to be just right here. So it's between 1 and 2, really, really close to almost 2 z-scores. Okay, so I take my value and I subtract the mean. So 68 minus 63.9 is the mean, and I divide by the standard deviation, which is 2.4. Okay, and let's get an answer. So I have 68 minus 63.9, and I divide by 2.4. So 1.71 is that z-score. Okay, so z-score 1.71, we said it was just below 2. Okay, so let's see about boys. 70 inches for boys. 70 inches is also between 1 and 2. Okay, well, let's figure out which one is more extreme. So 70 inches is right here, between 1 and 2. So I do 70, which is the value. I do the value minus the mean divided by the standard deviation. 70 minus 67 divided by 2.76. 70 divided by 67 is 3. I'm going to do some of this in my head. So I just need to take 3 and divide by 2.76. 3 divided by 2.76. And that is 1.09. Okay, so looking at these in respect to each other, 1.71 is further away from average than 1.09, right? So this person, this girl who's 68 inches tall, is a taller girl than this person who's 70 inches is a tall boy. Okay, so she is a taller girl than he is a tall boy, even though this boy is taller than what she is. Okay, so with respect to their gender, she is considered a really tall girl, and this is just probably an average boy. Okay, even though he is taller than what she is. Okay, so I hope that kind of made a little bit of sense here. It just allows me, by doing z-score, it allows me to compare two things that's not really fair to compare against each other, right? 70 and 68, I shouldn't compare those because boys are obviously taller than girls. So I convert them to a z-score, and then I can compare them. Okay, so last example, they want us to find the z value. If x is 18, so this is like my ACT score. Let's say my ACT score. The average ACT score is a 22. It's not, but that's what they're saying. Okay, and I don't even know that these are ACT scores. I'm just making these numbers up. So the average is a 22. My ACT score, and then the standard deviation is 3.1. Okay, so I take my value, which is 18. I subtract the mean, which is 22, and I divide by the standard deviation, which is 3.1. Okay, and I get an answer. 18 minus 22 divided by 3.1. I am at a negative 1.29. Negative 1.29. Okay, which if I put, like, let's say 22 here in the middle. Let's see, 22 goes in the middle. If I subtract 3.1, 22 minus 3.1 is 18.9. And if I subtract another 3.1, that's 15.8. Okay, so my value of 18 is just right below a negative 1. It's between negative 1 and negative 2. So right below a negative 1, that's where my negative 1.29 lives, okay? This is just how many standard deviations I am below, okay? All right, so I hope that all kind of made sense. This is completely foreign to you guys. If you like this stuff, take stats because we deal with this all the time, okay?